Okay, this is Ms. Whitaker, and we are going to ease into linear equations coming off of functions from a previous unit. We are working on this functions to linear equations activity, and it's dealing with perimeter. So we're just going to use perimeter to explore, and as it's going to lead us into the foundation for linear equations. All right, so the first thing we need to do in the upper left quadrant, we need to draw and label 3 rectangles with a constant length of 8 and varying widths. So I'm just going to draw 3 rectangles. All right, so with varying widths, but they all have lengths of 8. And the widths, let's say this is 2, let's say this is 3, and let's say that's 5. So you just had 3 rectangles, all have the same lengths of 8 and different widths. Could be any width. So now we need to find the perimeter of these, and we know that we just add up all the sides, or we can do 2 times the width and plus 2 times the length. The first one here, that's a 2 by 8, is going to be 20. So my perimeter is going to be 20 here, 20 units. The second one is going to be 22. If I add it all up together, 22 units. And then the third one with this 5 by 8 is going to be 26 for my perimeter. And that's just, again, that's just adding up all the sides. All right. So I have what they've asked for the upper left quadrant. Let's move over to the upper right. It says describe in words how you found the perimeter of the rectangles. Now you can say something like maybe you added up all the sides, or you did twice the length plus twice the width, or you added the length and the width and multiplied by 2. So go ahead and just write how you usually find perimeter up here. All right, so that's how I find it. Maybe you have something else. Just put up there, just write down how you find perimeter of your rectangle. And then it says to write an equation for the perimeter P of W. This looks like function notation, where W represents the width. So W is our input. So when we put something in, we get something out. And when we put something in, that's our width. And what we get out of it is the perimeter of the rectangle. So the equation for P of W, I would write something, well, we know it's, the way I did it was twice the width plus twice the length. And in this case, our length was 8 every time. So that's going to be 16. So I can just rewrite it as, for this particular problem, my equation for the perimeter would be twice the width plus 16. All right, so that's all we need to do for those 2 upper quadrants. Let's move on. All right, so for this table here on the lower left, I want you to go ahead and fill in the table here, fill in the values for the width when the perimeter are the given values that you see on the right. So for instance, when the perimeter is 26, what is the width going to be of that rectangle, knowing that my length is 8. 8 plus 8 is 16, so I have 10 remaining. Cut that in half, so my width has got to be 5. All right, I want you to do, just pause this video and do the remainder of these blanks for the width with the given perimeters. So go ahead and pause and fill out the table. All right, so you should have gotten these values that you see here. For the perimeter is 26, the width is 5. When the perimeter is 18, the width is 1. When the perimeter is 34, the width is 9, and so on and so on. And if you were to try to come up with an equation, you probably could, just after discussion and kind of guessing and checking, you could figure out what the equation would be. If you didn't know anything about this rectangle, if you were just looking at a relationship between the width and the perimeter, between this width and perimeter. So if you were just looking for a relationship, you could probably figure out eventually that you're going to have a relationship that looks like this. This twice the width plus 16 would give you your perimeter. All right, so let's move over to the lower right, graphing the data. So we're going to take what we did in the table here, and we're going to treat those as x and y values on our graph. X is our inputs, that's our width, and then y is the output, that's the perimeter for this problem. So what I'm going to do is I'm going to make my scale on the right my perimeter. I'm going to do a scale of every 2, and we'll just see how that goes. So go ahead and make your graph using the scale of 2 for your y's and 1 for your x's. So go ahead and fill that out. We're going to have a little bit of room up top, but that's okay. Not bad. Going up to 34. And then my width down here at the bottom can go by 1s. All right, so when my width is 1, my perimeter is 18, so I'm going to graph that point right there. When my width is 2, it's going to be at 20. When my width is 3, it's going to be at 22. And then I had one at 4.5. At 4.5, it's 25. So make sure that you are graphing correctly, and it should still line up. When the width is 5, it's at 26. At 6, it's 28. At 7, it's 30. At 8, we didn't have one for 8, and then at 9, we're at 34. So about right there. And you can see that this is a linear, it does make a line. If I connected the points, it is linear. So that's all we had to do for this one, but it's definitely showing a relationship there. And that is definitely a function. All right, let's go ahead and pause and finish this if you need to. And then we're going to move on to the back page. All right, so in this investigation, you're exploring the relationship between the width of a rectangle and its perimeter. Remember that the perimeter is the sum of the 4 sides of the rectangle, and for this particular problem, we had an equation of twice the width plus 16 was equal to the perimeter given a certain width. So remember W right here is our input, and then this whole thing is the perimeter when W is a certain value. So in letter A, it says, what does the point 6 and perimeter of 6, or P of 6, represent? So that point represents, go ahead and pause the video and write down what you think, and then bring the video back up. All right, I'm going to say that the point 6 and P of 6 represents the location on the graph when the width which is the input is 6, and the perimeter and the resulting perimeter, which is the output, is 28. So once we put 6 in for the W into our equation, then we get 28 as the output. And so that would look like 6, 28 would be that ordered pair and that place on the graph. But the actual, this ordered pair right here is just basically saying the width of 6 and then the perimeter when you plug in 6 for the width. So that's that ordered pair. Let's look at letter B. What width will produce a rectangle with a perimeter of 27? Write an equation that represents this and solve it. And find the point on the graph that satisfies the equation, the P of W equals 27. All right, so what I want you to do is set up an equation with the actual output, the Y, or the perimeter being 27, using the equation from above. So instead of P of W, you're going to put 27. You're going to substitute that in and then figure out what the width has to be. So you're solving for W. And then you're going to give the ordered pair for the point on the graph that satisfies the equation when the perimeter equals 27. So go ahead and pause and complete that equation and then check it in just a moment. All right, so my equation is going to start with 27 equals. That 27 represents the P of the W, the perimeter with the width of, and I'm looking for the width. So I'm going to plug in my equation of 2W plus 16. And now it's just a two-step equation, so I'm going to subtract 16 from both sides. And I end up with 2W is equal to 11. Divide by 2 on both sides. My W is equal to 5.5. And that gives me a point on the graph of 5.5, comma 27. So that's going to be the point on the graph that satisfies this equation when the perimeter is 27. All right, let's move on. All right, for letter C, we're supposed to find the value of W for which the P of W equals 34. And we're going to explain what this value means. So similar to above, go ahead and work out your equation. Go ahead and pause this video and work it and then come back to it for the answer. Okay, so for letter C, we were supposed to find the value of W, the width, when the perimeter was 34. So I plugged in another equation and plugged in 34 for my P of W. And I went ahead and wrote the equation we've been working with for this problem, which was 2W plus 16, because that length is always 8. And then I solved the equation, did a two-step equation, and got the width of 9. So with the width of 9, when I want to explain what this value means, it just simply means with a perimeter of 34, for this equation, the width must be 9 to satisfy this equation. So I'm definitely going to have a point at 934. So this is also a part of the function, but just understand when the perimeter is 34, the width must be 9 to satisfy that. All right, let's move on to the last one. What's a reasonable domain? Why is your domain reasonable, and what's the corresponding range? So going back to functions and talking about domain and range, remember, domain is all of our x values, it's all of our inputs, and then the range is the set of all outputs. So think about in this equation, what represents our inputs? Instead of x, we're using W for the width. So every time we put something in for W, we plug it into an equation and we get an answer, an output, which was the perimeter. Or we substitute for the perimeter to solve for what the width has to be. What does the input have to be to get a certain output? So we've done both things here, but let's look at what's a reasonable domain. Now we're talking about length and dimensions of a rectangle, and when we're talking about length, we know we never have negative lengths. So we can reasonably say that W, our width, is always going to be greater than 0. We can't have negative lengths. So we're always going to say it's going to be greater than 0. So just think of that rectangle, any size rectangle, it has to have some kind of dimension right here. We knew this was 8, but we knew there had to be some kind of dimension here, and we can't be 0, otherwise that's a line, not a rectangle. So we can't include 0, so it's not going to be equal to 0, but it is going to be everything greater than 0. Even if it's just a minute amount greater than 0, it's going to make a tiny, tiny rectangle. But that's okay. So our domain would be everything greater than 0, not including 0. And so if we plugged in 0 into that original equation, we put a 0 in there, 2 times 0 plus 16. We get 16 for the perimeter. Now we know that it's not going to ever be 0, but if we did put 0 in, the result would be 16. So my range, my output, has to be greater than 16 because that 16 was always constant when our length was 8. So this was a constant, never changing. So I know that my range, my P of W, that's my output, is always going to be greater than 16, and it's not going to be equal to 16. It's always going to be greater. For whatever value we put in for W, we get a value, an output for P of W. We know it's always going to be greater than 16 because we always knew that there was at least those lengths of 8, and we're just plugging in for the W. So you may want to just kind of summarize what we just talked about how the domain cannot be less than 0 because lengths can't be negative. So we know our width is always greater than 0, and if width was 0, we know the least amount would be 16. It's not going to even include 16 for our resulting perimeter, but it's going to be everything greater than that. And that takes care of this sheet. Make sure this is all completed before you move on to the homework.